Hello, honored algebra students. Mr. Lawrence here. I shouldn't say honors, I should say all my algebra students because my algebra kids will see this eventually. Anyway, hello, all of you. Today we're going to do a little more with solving equations by factoring. Second day on that. Naming polygons, which I'm expecting you to get, but we'll do a little bit with that later. And the commutative and associative properties, which showed up in a video the other night. And we're going to do a little more with it today. All right, so first of all, we're going to start off by solving equations by factoring. Now, you really need to close those holes. I try to give you instant feedback, or not instant, but as quick as possible on how to factor. So hopefully you're pretty good with these. Hopefully you're learning to close your holes. Please come see me. I would like to help you. Anyway, problem number one, I check for a GCF. I don't see one. So it's a trinomial. The lead coefficient is not 1. I'm going to multiply 3 times 10, and I'm going to get 30. I'm going to need two factors of 30 that add to get 11, right? Okay, well, let's see here. I'm thinking 6 and 5. Yeah, so I'm going to rewrite this as a polynomial with 4 terms, 3y squared plus 6y plus 5y plus 10, and that'll equal 0. Okay, I'm going to go ahead and do my grouping thing. Going to grab that sign. Got a plus in there. And I'm going to factor out a 3y, right? I'm going to factor out a 3y. So I'm going to have a 3y and y plus 2 will be left. And in the second quantity, I'm going to factor out a 5. And I will have a y plus 2. I see a y plus 2 is common to both, so I will divide out a y plus 2 from both numbers being multiplied, both products I can say. And so I'll get a y plus 2 as a quantity times a 3y plus a 5. Now that equals 0. Now, I have to solve now for y. And, these are different than two-step equations in the beginning, but now they're actually a lot like two-step equations. So, I'm going to take the first quantity and I'm going to set it equal to 0. Y plus 2 equals 0. I'm going to solve for y. And so for y is going to equal negative 2. Then I'm going to take the second quantity, set it equal to 0. And I'll get 3y plus 5 equals 0. I'll subtract 5 from both sides. I'll get 3y equals negative 5. Divide by 3, divide by 3. And then y is going to equal negative 5/3. So my solution to this is going to go right here. You can write it below, but I ran out of room. It's going to be y equals negative 2 or y equals negative 5/3. If you like to go negative 1 2/3, that's fine. It is not negative 1.6. That would not be correct. If you rounded to 1.7, it would be okay. I'd rather leave it as a fraction. So there's the answer I'm going to go with. All right, number 2. Remember, the first type of factoring you should always try GCF. I see a GCF hiding in here. Okay. Oops, let me change one small thing on this problem. Hold on. Okay, hope that doesn't screw you up. I want it to be 6x squared minus 24. I see a GCF hiding in there of 6, so I am going to factor out a 6. And so I will get 6 as a quantity of x squared minus 4. Now, I'm not done because this can be factored further, right? This is the difference of perfect squares, right? Because there's a perfect square minus a perfect square. I know the square root of x squared is x. I know the square root of 4 is 2. This is going to factor as 6 times x plus 2 times the quantity of x minus 2. And now most of you are smart enough, you can tell that x plus 2 equals 0 and x equals -2, or x equals +2. Again, you could write it out, x minus 2 equals 0, solve for x. I'll bet most of you can see it on this one. Can't see it on all of them, but there's your answer. Okay, I also want to change something on number 3. I just thought of something I'd like to change. Hold on. Okay, so let's see here. This third one, I've got a trinomial, but I see a GCF hiding here. I'm first going to factor out an x, and I'll be left with 4x squared minus 12x plus 9, right? Now, instead of multiplying 4 times 9, I'm going to notice that this is a perfect square, and its square root is 2x. This is a perfect square, that's 3. Multiply together, I get 6x doubled, I get 12. This is a perfect square trinomial. This will factor as x, and then I'll have two quantities, both having 2x and a 3 in it. And remember, there's a plus in the last term. This sign is going to show up twice. Boom, boom. All right. So now I'm going to solve. And you know what? I don't know if you realize this. There's actually 3 quantities here. There's only 2 different quantities. One of the quantities is 2x minus 3 equals 0. I'll solve for x. And I'll get 2x equals 3. For x is going to equal 1.5, right? 3 halves, 1.5. This quantity will get me the same thing. I'm not going to list it twice, but there's a quantity right here. And I'm going to set it equal to 0. Solve for x. Look at that, it's done. My solution for this problem will be x equals 0 or x equals 1.5. And there you go. That's it. Okay. Number 4. I'll tell you what, why don't you pause the video and see if you can do this one on your own. Okay. Hopefully, if you're watching this point, you've already attempted it. I noticed that there's no GCF other than 1. 1 doesn't do me anything. This is a perfect square with x, and this is a perfect square with 5, but there is no such thing as the sum of perfect squares, right? Sum of perfect squares? Nope, no such thing. This part here is prime. Well, if it's prime, then it can't be factored, right? If it can't be factored, right now I can't solve it, and so there's no solution to this problem because I'm asked to solve it. So this would have no solution. The equation is not prime. The expression x squared plus 25 is prime, meaning it can't be factored. But there is no solution for x. There is no number I can put in and square it. Like if I put -5 in and square it and add 25, that will not equal 0. No way, no number. Okay, now we need to talk about naming. Well, let's see here. This first one here, well, let me get a good color here. Something I haven't used, something kind of stands out. Okay. Yeah, how about this brown? That'll look good. Okay, so this one here, it has 3 terms, so it's a trinomial, right? Trinomial. And the highest power is 2. This is a quadratic trinomial. Okay, this one, number 2, only has 2 terms, so it's a binomial. And its second power, so it's a quadratic binomial, right? Quadratic binomial. Remember, 1 term is monomial, 2 terms binomial, 3 terms trinomial, 4 terms or more polynomial. First power linear, second power quadratic, third power cubic, and fourth power is quartic. Okay, this one here, I see 3 terms, so it's a trinomial, and I see third power. It's a cubic trinomial. Okay, and this one here, 2 terms, squared is a quadratic binomial. There you go. All right. Well, number 5 and number 6, your job is just to name them. Go ahead and pause the video, see if you can. If you're still watching, here come my names. This would be a cubic binomial, and this one will be a quartic trinomial. Okay, finally, on numbers 7 and 8, you have to identify which property is being demonstrated. Now, 7, 8, 9, and 10, we know three properties really well. Well, we should. Associative property, which is where the grouping changes, and that has for either addition or multiplication, right? Okay. There's the commutative property of either addition or multiplication. You might be thinking what that third property is. Well, I'm not going to tell you. I'll bet you'll figure it out on problem number 9. Okay, so problem number 7, what property is being demonstrated? Well, let's see here. I have the quantity of x plus y times 5, and then I have 5 times quantity of x plus y. What changed? The order changed. That means this is the commutative property. And what changed? What, did the addition change or did the multiplication change? That's how you know there's multiplication here, multiplication here. It doesn't look like the addition changed order, did it? I didn't ever say y plus x. So this is the commutative property of multiplication. All right, number 8. I've got 3 times the quantity of x plus y plus z, and 3 times the quantity of x plus the quantity of y plus z. So let me see what changed. It looks like the grouping changed, right? I had x plus y grouped together, but here I have y plus z grouped together. So this would have to be the associative property. Now, is it of multiplication or addition? Well, where the parentheses take place, it's all addition, right? So it's the associative property of addition. Okay, number 9, you should know what this is. If you don't, whoop, whoop should be a giveaway because that's how they got 10x minus 12, right? That's the distributive property. Okay. Now, problem number 10, I'd like you to write down, there's A through F, and I want you to see if you can name which property has changed, allowed the change to take place. They're going to be different. Just ask yourself, did the grouping change or did the order change? So the first part, you have the quantity of x plus y plus z. Now, the next line says x plus the quantity of y plus z. Ask yourself, did the order change or did the grouping change? And then write the appropriate answer. Okay, so let me see here. All right, you go ahead and pause the video and see if you can get it right. Okay, my answers will appear shortly. Okay, here come my answers, just checking my time. This is good. All right, looks like I changed the grouping, so this is the associative property of addition. Okay, and then inside the group, the y and z change place. In other words, they change order, so this is the commutative property of addition. Okay, then I have an x plus z. Looks like the x plus z got grouped together instead of the z plus y. It was the z plus y, now it's the x plus z. This is the associative property once again. All right, then inside that group, the x and z switch positions. That's the commutative property of addition. Then the parentheses moved to from the z plus x to x plus y, right? So that would be the associative property once again. And then finally, inside the quantity, x plus y became y plus x. Well, that is the commutative property of addition. And there you go. All right, good little review video. We'll get some practice with that. I believe you're going to be having honors this coming week. You're going to be having a test on, I think that would be Thursday the 7th, right? Okay, now, regular algebra, you're watching this video at a later date. I can't promise when your test will be. I won't know until we get closer. All right, Mr. Lawrence signing off. Good night, everybody.